recording that.
So,
Okay.
so the next part here from the statics video is vector addition, right?
Yeah.
And this is just kind of a continuation of what we were talking about with regards to trigonometry. We're going to go through a quick little review
Refresher.
of that on here, and then we'll get straight into vectors.
Yeah.
So, what do we remember of trigonometry? We've got right triangles. We've got obtuse and acute triangles. We can divide those up into being right triangles. All of the sum of the angles equals 90 degrees. Acute means
180 degrees.
Or 180 degrees. Thank you.
Yep.
And then obtuse is less than is greater than 90. Acute is less than 90. And then if we get back to this one more time with the chant. Sokatoa, Sokatoa. Yeah, they got it.
Hopefully.
That should be all you need to memorize what goes on with a triangle here on this slide. So we can use these to figure out that for each of the angles.
Right.
So how does this relate
To forces.
to forces? Right? Like a force isn't a triangle.
No, it is not a triangle. But we can describe it as a triangle.
But we can describe it as a triangle.
And we can describe forces relative to each other as triangles.
Yeah, absolutely. So let's expand upon that.
Yeah.
What do you have in a force? What is a force?
Well, I mean, so like we can describe things like what are common things that people would associate with force. I think there's like we can have something that's like a pressure.
Mm-hmm.
We could have something that's like there's the force of gravity that is pulling us towards the earth.
There's something right there.
Yeah.
It's pulling us towards something. So a force necessarily has to have a direction to it.
Yes.
And so a direction can always be described as an angle, but it isn't just a direction. There's also a magnitude of it.
Right.
How much force?
Yes.
You know, like clearly, you know, you take Carl
Yeah.
versus myself. You know, we exert different forces on the ground.
Physically different forces on the ground as you walk across them. And
Yeah.
it's because they are two different sized humans.
Yeah.
And one of them weighs more than the other.
Yep. Simple as that.
But what is so like let's break that down in terms of like the explicit components that make it a force, right?
Yeah.
We have directionality because of because of gravity. We are being pulled in a particular direction, which is towards the center of the planet,
Mm-hmm.
right? And then we also have the magnitude, which is the amount of weight that a person is in this circumstance, right?
In this circumstance, yeah.
Like we're measuring that magnitude of force
Mm-hmm.
as the unit pounds if you're in the U.S. or kilograms if you're everywhere else in the world.
Yeah. And so we've got magnitude and direction.
Yeah.
So the direction kind of indicates an angle that it's going off, but it could also be going in the opposite direction along
Right.
that same line. So there is this thing called a sense, which is basically an arrow that we say that the force is going in this direction, right?
Right. It indicates the direction of force.
Yeah. And then you have the point of application, and this is the point, and it could be at the head of the arrow, it could be at the
base.
the tail of the vector.
Yeah.
But that is where it's applied to an object.
Yeah. We should be particular with our terminology here. When we're talking about the vector, like there's the point, and then there's the tail. Those are the opposite things. So Jason was correct here in his use of terminology. Do not call it the base. Call
Yeah.
it the tail. If you talk to another engineer, they will shame you if you don't use the correct terminology.
Yeah. So that basically covers the characteristics of a force, right?
Yeah.
And it's like, now we've gotten way more specific than how we normally talk about it.
Yes.
You know, like we're not sitting here saying, use the force.
Yeah. It's not some anamorphous magic.
Yeah,
like-
and that's going to happen all the way through statics. we're
Yeah.
going to be using terms that you already use in normal everyday spoken English. You're just going to understand what they actually mean.
Yeah, and you're going to find out that they mean very particular things, and that their use in like common English is like a distortion of their true meaning.
Yes.
It's like we have appropriated a word to describe a more general property than what that word actually describes.
Yes. So we'll get more into that when we talk about stress.
Yes.
All right. So there are two different types of things that we're going to be working with here. There's scalar quantities, and that's a quantity that has a magnitude only, and it's because, and when we use it in statics, we're often talking about like what it is in the x direction and what it is in the y direction, so that actually narrows out the directionality of it.
Yeah, we're kind of separating, like if we're talking about a scalar, we're talking about like this, we're separating out magnitude and direction from each other.
Yes.
We're talking about the components.
We're only talking about a magnitude only,
Yeah,
rather than a degree.
yeah,
So a scalar quantity can also be used to talk about a volume of water, a population, a duration of time. It's a singular magnitude
yeah.
only.
It doesn't have directionality associated with it.
Yeah. Whereas a vector quantity has magnitude, direction, and sense.
Yeah,
And vectors are basically just a line with a pointy head on it.
yeah, and they're pointing in a particular direction.
Yeah.
And that sounds potentially like abstract. We're going to tie this to practical application.
First, we're going to deal with it in
Yeah.
terms of like, using it for pounds. We're going to use do some exercises around these.
Yeah.
You're going to learn how to do these items.
Yeah, and what we're essentially building towards is a concept that we use a lot, or a tool that we use a lot in different applications. And it's just generally called vector math, and using vectors to describe forces and directions relative to one another, so you can characterize like how a system behaves either statically or at a particular moment in time if it's a system that changes over time.
So first, we're going to learn these kind of blandly.
Yeah.
But you'll be applying these to whenever you're pulling on something
Yeah.
from a specific direction. You're going to be using these for whenever current lags voltage in AC circuits,
Which we will definitely talk about this quarter.
we will definitely talk about this quarter. So yeah, and it all boils down to vector math.
Yeah.
All right. So we're gonna take a break here, and we're gonna come back, and we're gonna do a few practice examples on the board here. So you'll see that in part 2 of this video
Yeah.
on vector math. We'll just be solving this right here. We're gonna figure out exactly what the scalar components of this are.
Yeah. And we're going to break down kind of exactly like how you go about working with a vector on a plane.
Yeah.
So we'll see you in part 2.
We'll see you in part 2.